Have you ever gazed up at the night sky and wondered, how will it all end? It's a question that has captivated humanity for millennia. Will the stars we wish upon simply fade away? Will the universe collapse in on itself in a fiery implosion? Or does something even more bizarre await us in the distant future? In this video, we dive into the leading scientific theories about the ultimate fate of the universe. From the chilling Big Freeze to the mind-bending Big Rip or even a false vacuum, we'll explore the science, the evidence, and the implications of each scenario. Fasten your seatbelts and prepare to expand your cosmic perspective. We're about to confront the ultimate mystery, the end of everything we know. Before we delve into the various ways the universe might end, we must first understand its current state. Our journey begins with a groundbreaking discovery by astronomer Edwin Hubble in the 1920s. The universe is expanding. Like raisins in a loaf of bread rising in the oven, galaxies are moving away from each other. This expansion is driven by a mysterious force known as dark energy, a form of energy that permeates all of space and counteracts the pull of gravity. Imagine it as a cosmic anti-gravity pushing everything apart. The discovery of dark energy revolutionized our understanding of the cosmos. The expansion of the universe is the foundation upon which the grand cosmic drama unfolds. It's the stage upon which the final act will be played out. As the universe expands, the distances between galaxies grow. Over incredibly long timescales, this expansion will impact the way stars form and galaxies evolve. Now, you might be thinking, well, if the universe is expanding, won't it just keep expanding forever? It's a logical question, and it leads us to one of the most widely accepted theories about the universe's end, the Big Freeze. But before we venture into that frigid future, let's consider other possibilities. What if the expansion isn't constant? What if the forces at play in the universe are engaged in a cosmic tug-of-war? Could the universe's expansion slow down, eventually coming to a halt? And if so, what would happen next? These questions bring us to the intriguing possibility of the Big Crunch. Imagine the universe as a ball thrown upwards, reaching its peak, and then falling back down. But the universe's end might be far more explosive and violent than a simple contraction. There's another possibility, the Big Rip. Let's begin our exploration of the universe's potential endings with the most widely accepted theory among cosmologists, the Big Freeze, also known as the heat death of the universe. This scenario paints a picture of the universe's future that is both fascinating and, some might say, a bit melancholy. Imagine a universe where the expansion never stops. As the universe continues to stretch, galaxies drift further and further apart, becoming increasingly isolated islands in the vast cosmic ocean. The space between them grows, making it harder for light and matter to interact. It's a slow, drawn-out farewell on a cosmic scale. Now let's fast forward to a time long after our own sun has exhausted its nuclear fuel and shrunk into a white dwarf, a faint ember of its former glory. In this distant future, the formation of new stars will dwindle as the supply of hydrogen, the essential fuel for stellar fusion, becomes increasingly scarce. Galaxies, once vibrant with the birth of new stars, will slowly dim and fade, transforming into cosmic graveyards populated by stellar remnants, white dwarfs, neutron stars, and black holes. But the story doesn't end there. Remember that ever-present expansion? As the universe continues to stretch, it also cools. This cooling effect is a consequence of a fundamental law of physics, the conservation of energy. As energy spreads out over an ever-increasing volume of space, its intensity diminishes, leading to a gradual decrease in temperature. In the far, far future, trillions upon trillions of years from now, the universe will reach a state of maximum entropy, a state of thermodynamic equilibrium where everything is at the same, extremely low temperature. We've explored the possibility of the universe expanding forever, slowly winding down like a clock running out of energy. But what if the expansion we observe today is just one act in a much grander cosmic drama, a drama with a plot twist worthy of the most imaginative science fiction? What if the universe, instead of stretching into oblivion, reverses course and collapses back in on itself? This is the essence of the Big Crunch, a scenario where gravity stages a comeback, pulling the universe back together in a fiery, spectacular implosion. Imagine the universe as a cosmic boomerang, flung outwards by the Big Bang, reaching its peak expansion, and then slowly but surely arcing back towards its point of origin. This reversal of fate hinges on a critical factor: the balance between the outward push of dark energy and the inward pull of gravity. If dark energy weakens over time, or if the total amount of matter and energy in the universe exceeds a critical threshold, then gravity could eventually regain control. Galaxies, currently drifting apart, would begin to converge, drawn together by the irresistible allure of gravity's embrace. The cosmic expansion we observe today would gradually slow down, eventually halting altogether. Then, the grand contraction would begin. The universe, once a vast and ever-expanding expanse, would shrink, with galaxies rushing towards each other like long-lost lovers. As they collide and merge, the universe would become increasingly dense and hot, a cosmic pressure cooker on a grand scale. We've explored the slow fade of the Big Freeze and the fiery collapse of the Big Crunch. Now let's turn our attention to a far more dramatic and violent end for the universe, the Big Rip. Brace yourselves because this scenario is not for the faint of heart. Imagine a universe where dark energy, that mysterious force driving the universe's expansion, doesn't just remain constant or even gradually weaken. Instead, it grows stronger over time, like a cosmic hurricane gaining strength with each passing moment. This intensifying dark energy would have a devastating effect on the fabric of the universe. As dark energy's influence grows, the universe's expansion accelerates at an ever-increasing rate. It's not just galaxies moving apart. It's as if the very fabric of space-time is being stretched, like a rubber sheet pulled taut, threatening to snap. This relentless stretching would have catastrophic consequences, tearing apart the universe from the inside out. First, galaxies would be ripped apart as the expansion of space overwhelms the gravitational forces holding them together. Then, stars would be torn from their galaxies, flung out into the ever-expanding void like castaways on a stormy sea. But the destruction wouldn't stop there. As the Big Rip approaches, the ever-increasing strength of dark energy would begin to affect objects on smaller and smaller scales. Planetary systems would be disrupted, with planets torn away from their stars and sent hurtling into the abyss. We've journeyed through scenarios where the universe freezes, crunches, and rips apart. Now let's dive into a possibility so strange, so counterintuitive, that it seems ripped straight from the pages of a science fiction novel: the false vacuum. But unlike some science fiction, this concept is rooted in the mind-boggling world of quantum mechanics. To understand the false vacuum, we need to think about the universe in a completely different way. Imagine the universe not as a smooth, continuous fabric, but as a bubbling, fluctuating sea of quantum fields. These fields, governed by the laws of quantum mechanics, are the fundamental building blocks of reality, giving rise to the particles and forces we observe. Now, imagine that the universe, at its most fundamental level, exists in a state known as a false vacuum. This doesn't mean it's a fake vacuum like you might find in a broken appliance. Instead, it refers to a state of temporary stability, like a ball resting precariously in a shallow dip on a hillside. This false vacuum is metastable, meaning it appears stable but possesses the potential to transition to a lower energy state, a true vacuum, with profound consequences. It's as if the universe is holding its breath, waiting for something to nudge it into a more stable configuration. But what could trigger this cosmic exhale, this catastrophic transition from a false vacuum to a true vacuum? That's where things get really interesting and a bit unnerving. According to quantum mechanics, random fluctuations can occur in the quantum fields that permeate the universe. These fluctuations can create tiny bubbles of true vacuum within the false vacuum, like seeds of change waiting to sprout. Most of these bubbles are tiny and short-lived, collapsing almost as quickly as they form. We've explored the science behind the universe's potential endings, from the slow freeze to the quantum reset. Now let's embark on a journey of philosophical exploration, pondering the profound implications of these scenarios for time, matter, and life itself. If the universe were to end in a big freeze, would time continue to tick on? Or would time become meaningless in a universe devoid of change or activity? Would time become a frozen river, forever locked in stillness? And what of matter? As the universe expands and cools, would matter cease to exist or persist in a diffuse state? Could any form of life survive the universe's demise? Would life endure in the cold, dark expanse or be extinguished with the stars? It's a mind-bending concept, challenging our linear perception of time. Contemplating these cosmic possibilities can enrich our understanding of our place in the universe and inspire awe and wonder at its grandeur and mystery. As we conclude our exploration of the universe's ultimate fate, we're left with a sense of profound wonder and a thirst for even deeper understanding. While the end of the universe might seem like a distant and abstract concept, contemplating these cosmic possibilities offers a unique perspective on our place in the grand scheme of things. It reminds us of the vastness of time and space, the incredible journey the universe has undertaken from its fiery birth to its eventual demise. It highlights the interconnectedness of everything, from the smallest subatomic particles to the largest cosmic structures, all dancing to the tune of the same fundamental laws of physics. Though the universe's end might seem like a bleak prospect, it's also an invitation to cherish the present moment, to marvel at the beauty and complexity of the cosmos, and to continue exploring, questioning, and pushing the boundaries of human knowledge.